Hello students, welcome to the second lesson of this module 4. In this module, our goal is to solve trigonometric equations. In the first lesson, we studied about the inverse trigonometric functions which are essential in solving any equation. Right? In this lesson, we begin actually solving the equations now that we know how the inverse of a trigonometric function works. But we will first solve some basic equations. So what we mean by a basic equation here, basic means it only involves x as the angle, not 2x or half x, and not and that value, that trigonometric function equal to some number. Okay, not involving multiple trigonometric functions together. Nothing complicated, basically. Okay, and in that also, as you will see, there are going to be some special values that we need to take care, which we call special equations. Like some particular values have a unique type of solution, whereas all other values will fall in the general category. Okay, we will analyze all of that, and we will also do this analysis on, if you know one solution, how can you use that information to get other solutions. For sine, how to do that, or cosine, how to do that, and that kind of discussion. Okay, so let us begin. The special equation cos x equals 1. Firstly, but at this point we all know very well cos of 0 is 1, right? So cos inverse 1 is 0, and this is, if you look at the interval from 0 to pi. Okay, it starts at 1 and then goes to 0 and then goes to -1 from 0 to pi, right? That shape of cosine. But we know the function cosine itself is periodic with period 2 pi. So what happens? From 0 to pi, it goes to -1, then it starts back up, right? And it comes back to 1 again at 2 pi. So that means from 0, it will repeat again at 2 pi. So any multiple of 2 pi can be added to obtain additional solutions. So one solution is 0, and then you can get the same thing again at 2 pi, at 4 pi, 6 pi, and so on. Similarly, on the left, you could move to the left 2 pi, and at negative 2 pi, negative 4 pi, and so on. So this is a special situation and special type of solution. The solution set of this equation is now the general solution set. Okay, I will also talk about that here. This one here is a particular solution, right? One particular solution, one value. Here what we are writing is general solution, which is like the general set of solutions. Okay, the solution set is x such that x equals 0 plus 2k pi. You don't have to write 0. I'm just writing it for emphasis. Okay, a multiple of 2 pi, right, can be written as 2k pi. Okay, where k can be any integer. All right, and this concept can be understood if you look at either the graph of the cosine function or the unit circle. I will show it both ways, so you can, whichever way you remember at any point of time, you can use that concept. If you look at it on the unit circle, the x coordinate is 1 at angle 0, and the only time it becomes that again is when you make one full cycle, 2 pi, and you're back there again, right? So plus 2 pi, or you could go clockwise and say minus 2 pi, right? That's how at every multiple of 2 pi, you get the same value again. So this is a special equation, okay? Um, I'll tell you what, like you might say, no, isn't that true for every other angle? Yes, it is. But there is more to the story, which you'll understand when we look at other angles. Okay. One more thing I can show you here is maybe the graph will help understand that better. Why is it special? Okay. If you look at the graph of cos x, this is the shape, right? The fundamental cycle, the fundamental period. And where are we? This is at 0, 1, and you come back at 2 pi 1, right? Not in between. Okay, in between you don't get 1 again. And if you go to the left at minus 2 pi, now you can continue like that, and at minus 2 pi again you are at 1. Hence this special solution. Okay. Similarly, cos x equal to 0 is also another special solution. How? Okay. Let us first look at the um, least positive value that you get when you try to solve it. If you go anti-clockwise, the x coordinate is 1 when the angle is pi over 2, right? This point is 0 comma 1 when the angle is pi over 2. So cos inverse of 0 is pi over 2. Okay. Since the x coordinates are equal to 0 at two places on the unit circle, okay, another value where it becomes equal to 0 is 3 pi over 2, right? Pi over 2 and 3 pi over 2. And you would say, your general solution. Okay, now what is happening? What is the difference between this pi over 2 and 3 pi over 2? You added pi, right? Plus pi, you got that. And from there, if you do another plus pi, you'll go reach again on the pi over 2 and round and round. You keep adding pi, you get this. Okay. So your general solution you can write will be pi over 2 plus 2k pi. Not 2k pi, plus k times pi. Okay. Uh, what we're writing here is general solution. Okay. General solution is, I would say, where a is any integer. Okay. Graphically, see here. Cos x equal to 0 here at pi over 2. Again at 3 pi over 2. If you go to the left at minus pi over 2. So every pi block away, this length is pi. Every time you move by pi, you get another 0. This is also special. It looks as if, if you were to look at only this value, you might think it is period with period pi, right? Because the values are repeating at pi, but that's not the case with other angles. Hence, this is also a special equation. Okay. Now let us look at another in between value. Not 0, not 1, something in between, say half. Okay. And you can see in this unit circle here, where do we get the coordinate half? X coordinate, you might remember this about the unit circle, right? Half and root 3 over 2. And that happens at 230 degrees or 60 degrees. Okay. Which is pi over 3 in quadrant 1. However, cosine is the x coordinate, right? And the x coordinate is positive in the first quadrant as well as the fourth quadrant, where theta, now if you make this full angle rotation, you can say theta is, if that angle is pi over 3, you can call this angle down here as, how many? Total will be 12 pi over 3, 6 pi over 3. Out of that, 5 are taken. So 5 pi over 3. Or if you want to write as a negative angle, you will say minus pi. Okay. I'll count and show you. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Okay. In fact, you can draw a vertical line to locate the other angle. This is the interesting part, and I ask you the question, think why. Okay. For any angle, in fact, that was the true in case of the 0 also, and this, for every any angle it is true, but it is particularly interesting or more easily seen when the angle is other than 0 or 90. Okay. For any angle, if you take our vertical line and draw from that down to the opposite side, you get another angle where the cosine has the same value. Okay. Why? If you have thought about it, now you check. The answer is because the x coordinate is the same. If you look at a vertical line, the x coordinate is the same, and that is cosine. Okay. All right. What that means is, for any value other than 0 and 1, there are going to be two angles which will have the same cosine value. And you can verify that or see it if you look at the graph also. Look at a general graph of a cosine function. And if you take any horizontal line at a random point, random height, it will intersect at two different points on that interval, right? 0 to 2, on that interval of length 2 pi. Okay. So you would say the general solution is x such that x equals, now we know the concept of adding 2 pi repeatedly, right? So you can say pi over 3 plus 2k pi if you go with the angle pi over 3 in the first quadrant, or 5 pi over 3 plus 2k pi. Either of this angle, take as the like base angle and then add 2 pi, multiples of 2 pi for more solutions. Okay. And remember, I had said that 5 pi over 3 can also be written as minus pi over 3 if you go clockwise. So this solution that I wrote here can be written alternately as pi, no, 2k pi plus and minus pi over, because this 5 pi over 3 can also be interpreted as minus pi over 3. Okay, so basically it is pi over 3 plus 2k pi or minus pi over 3 plus 2k pi. Okay, and then I'm rewriting it as 2k pi plus minus pi over 3. K is the integer. Okay, now I will summarize what we discussed in this page. Basically three things. Cos x equal to 1 is a special equation whose solution is 2k pi. Cos x equal to 0 is another special equation and its solution is pi over 2 plus k pi. Okay, and for any other general angle, the solution is that value plus 2k pi or another value obtained by drawing the vertical line in the unit circle or just taking the minus of that angle. Okay, plus 2k pi. All right. Before we move on, I would like to add that if you think deeply, the first two equations that we said are special are really not that special. You could simply take the third general solution that we did in like the third example and apply it, and you would get the previous solutions also. So all of them are basically the same. Okay. And what is the main idea? The main idea is cosine is defined as x coordinate. So whenever you have one angle, okay, you can get the other angle by looking at its reflection on x-axis or by drawing the vertical line, which alternately can be obtained as negative of that angle. Okay, if one angle is like theta, the other angle is minus theta. Okay, between 0 and 2 pi. And actually let me write that here. Cos cos theta will always be same as cos minus theta. Okay, so these will be the two angles which are your base solutions, and then you add multiples of 2k pi, 2 pi. Okay, and remember cos minus theta basically means 2 pi minus theta, right? 2 pi is like 0, full circle. Okay, so theta and 2 pi minus theta, if you want to find positive solutions, those will be your solutions for any cosine basic equation, theta and 2 pi minus theta. Okay, I'll write here theta and 2 pi minus theta for cosine. Maybe that's the idea you can remember. All right, let us solve some basic sine equations. Say you have sine x equals minus half and x is in degrees. Okay, now when do I get sine x equals minus half? In the first quadrant, sine is positive. Second quadrant also sine is positive. Sine is negative in third and fourth quadrant where the y coordinate is negative, right? So the simplest way to answer this would be, when is sine equal to half? That is at 30 degrees, but we are looking at minus half, right? Minus 30 degrees. Okay. Many ways to think about it. one thing is sine of minus theta equals minus sine theta. Sine is an odd function. Okay, so if you are looking at minus half, the angle is minus 30 degree. Okay. Other way of understanding is if the sine value is negative, you are definitely in the below the x-axis. So the best way is from first quadrant you can go to the fourth quadrant, and that angle will be minus 30 degree. Okay. Now, is that the only solution? No, of course not. Sine is negative, we said, in the third and fourth quadrant. So quadrant 3 and quadrant 4. What we wrote is in fourth quadrant. Minus 30 degree is here. And how do I get the angle in the third quadrant? You go horizontally. And that also will have the same sine value because both of them have the same height from the x-axis. See here, this is x-axis here. Okay. So they have the same y coordinate, which is the value of sine. Hence, you can get the other angle by moving horizontally to the other side of the unit circle. See these ideas, okay? For cosine, you go vertically down. For sine, you go horizontally across. Okay? And how would I get the other angle then? What is the relation between this minus 30 degree and that? And if you think about it, okay, the answer is from here to here, you do that pi, 180 degree rotation, and then this extra amount of the same value, right? 30 degree, so plus 30 degree. So you can write the other two solution as pi or 180 degree. Let me write in degrees. Okay, 180 degree plus 30 degree in quadrant, well, 3. Okay, so minus 30 degree in quadrant 4 and 180 degree plus 30 degree in quadrant 3. This is 210 degree. Minus 30 degree is same as, by the way, okay, minus 30 degree is same as 330 degree if you go anti-clockwise. Okay, and here also I ask the same question. You can get this by drawing the horizontal line. Why? And you know the answer. It's because that's the y coordinate. Okay, so what would be your general solution, right? The concept is same. Like cosine, sine is also periodic with period 2 pi. So if two of your solutions are 30 degree and 200, not 30, 330 degree and 210 degree in third quadrant and fourth quadrant, these are your base solutions. Now every other solution you can write as a that angle plus multiple of 2 pi or 360 degree. Okay, and generally we write using the smallest positive angle. Okay, so we would say 200 and the smaller of these two is 210 degree. Okay, 210 degree plus k times 76 degree or 330 degree plus k times 360 degree. Okay, those will be all possible solutions where k is an integer. Okay. And if you're asked to give only, like, we using only one angle, you can always give with the smaller of the two positive angles. Okay. All right. Solve tan theta equals 1. Okay. So for sine and cosine, we saw this concept that there are going to be two angles between 0 and 2 pi. And once you find those two angles, you can add multiples of 360 degree or multiples of 2 pi. Okay. Let us move on to tangent. Solve tan theta equals 1 on the unit circle that happens at 45 degrees, right? Root 2 over 2, root 2 over 2. Tangent is y over x. So in quadrant 1, that happens at angle pi over 4. Okay. Tangent is also positive in the third quadrant. It is the ratio of y and x. In the third quadrant, both are negative. So the ratio is again same, right? 1 positive. But how do I get from pi over 4 to same value here? We added another pi, right? And that is in fact the period of the function tangent. So all values of theta will be obtained by adding k times pi to the values obtained by finding tan inverse 1. Okay. So the solution general would be x such that x equals pi over 4 plus k times pi, where k is any integer. That's it. And now you might wonder, did we not do something like this before? We did that for the special case of cosine equal to 0. Okay, we said that the solution would be pi over 2 plus k pi, right? In the same way, here we are saying the solution of tangent is pi over 4 plus k pi. The difference is, for the cosine, that was the special angle. There is only one angle where that is true, which is 90 degrees. Okay, when the angles are exactly pi apart. You have to see the unit circle. Okay, here, at 0, 1 and 0 minus 1, the cosine has the same value, 0, and the angles are pi apart, differ by 180 degree. That doesn't happen for any other case, right? Because the concept in cosine is to draw this vertical line. And if it is not exactly on the y-axis, the difference between those two angles is not going to be 180 degree. Okay, it's not going to be pi. No, it's going to be theta and minus theta. But in the case of tangent, you are going from first quadrant to third quadrant or second quadrant to fourth quadrant diagonally opposite, and that's always at a difference of pi, you know. So this technique, theta plus k pi, works for all values of tangent, not just one special case. That is the difference between cosine and tangent. Okay, that is our difference. Okay, moving on. Use the same idea and solve tan theta equals minus tan alpha equals minus root 3. Okay. Now alpha is negative, tan alpha is negative in the second and fourth quadrant. So if you are saying negative root 3, you are here. and that is 1 pi over 3, 2 pi over 3, right? The angle is 2 pi over 3. Okay, so this is 2 pi over 3 in quadrant 2. But then you can keep moving up. I'm writing in radians. You should write in degrees. In degrees, 120 degrees. Okay, in quadrant 2. So the general solution would be, I'll write here, x as that x equals 120 degree plus k times 180 degree. From that 120 degree, if you add 180 degree, you reach the fourth quadrant where the tangent has the same value. Okay, and then so on and so on if you repeatedly add. Okay, let us solve another problem. Find all angles in degrees for which sine alpha is 0.158. Okay, now this you need to use calculator to solve. First, which quadrants? Alpha, if sine alpha is positive, you can go ahead and write your answers, okay, and check with me. You are either in the first quadrant or second quadrant. Okay, in the first quadrant, if you use the sine inverse function on your calculator with calculator in degree mode, you'll get the value. Please do it and check with me. I'm also going to write it here. Okay, I found it to be 9.09 degrees. Okay, round it to two decimal places. So if you do 180 minus 9.09 degree, you will get 170.91 degrees, right? Okay. And why is this idea of subtracting from 180 minus theta, which I want to write now here in general, okay? If your general equation is sine x equals sine theta, theta is some specific value, okay? Then your solution is either theta or 180 degree minus theta. And why is that? Because theta, if theta is positive, think of theta as a small angle in the first quadrant. 180 minus theta is in the second quadrant. In both of them, sine theta is positive, right? And that's the angle you will get exactly if you move horizontally to the other side. I want to illustrate that with the unit circle diagram as well. If this angle is theta, what you get here on the other side, okay, I zoom in and show. This measure is theta, right? But from 180, you are subtracting theta. So the other angle measured clockwise would be 180 minus theta. Okay, that works very well in the first quadrant and second quadrant. You might wonder, does it work in third and fourth quadrant? And the answer is yes. Okay, if you are in this quadrant, say, and I'll use negative for calculation purpose, that angle is minus theta, right? What is the correspondingly equal angle? Which is here. And how do you get that angle in the third quadrant? You get that angle starting from origin. Okay, I will remove the other angles now. Remove this. remove this. Okay. Now, if you want to get this angle in the third quadrant, you can go clockwise 180 degree and then another theta. I showed this earlier with 30 degrees. Okay. So that is 180 and this is plus theta. So basically it is 180 degree plus theta, which you can interpret as 180 degree minus theta, right? So for minus theta, it is 180 minus theta plus, for plus theta, it is theta and 180 minus theta. So both ways it works. What I'm trying to say is it always works if you take the two angles to be theta and pi minus theta or 180 degree minus theta when you are solving a sine equation. Okay. Hence this calculation. So your general solution is 9.09 plus k times 360 degree or 170.91 plus k times 360 degree. Okay. So what I was talking about earlier is written as a note. Sine theta is equal to sine 180 degree minus theta for any theta. That's important. Positive or negative. Okay. All right. Now let us solve a slightly complicated equation, but basic in terms of like the angle still S. Okay. And the condition given to you is that angle should be between minus pi over 2 and pi over 2, which is basically the fundamental cycle or fundamental period of sine, right? Okay. Solving it, I have to solve for sine, right? And that means I have to write it as 4 sine s minus 7 equals b. Switch the sides. Then you can say 4 sine s equals v plus 7. Take the minus 7 to the other side. And you can say sine s equals v plus 7 divided by 4. Okay. And you can say s will be sine inverse b plus 7 over 4. Okay. That will be the value. Now what exactly will be the value of s depends on the value of v. Okay, but that's how you can write the equation. Okay, and when will it have a solution? There is a way to find that. Okay, I'll not get into that detail here. There are certain values of v for which it will have a valid solution, right? Obviously, because you cannot say sine inverse of 2, for example. No, sine inverse can only be computed if it is between minus 1 and 1. So your value of v should be such that this quantity is between minus 1 and 1. And you can use that inequality and get the range for v if you want to get into that detail. Okay, but we will leave it at this. Okay. Solve sine theta minus root 2 equals 0. And the answer is sine theta equals root 2, which is greater than 1. Right? Square root of 2 is 1.4142, more than 1. Not possible. Okay, so the answer is no solution. Okay. Find the inverse function and state its domain and range. I think we have done a similar problem in the previous exercise also. So hopefully this will be a easy go. Only thing is now it involves an angle, so we'll be careful about that. Okay. The routing process. First you say y be that function. Now you'll solve for x. Okay. So you'll say cos 3x is y, which gives you 3x is cos inverse of y, which means x is 1/3 of cos inverse y. Okay, at which point you will interchange x and y. And you get your solution. Y, which is the inverse function now, is 1/3 of cos inverse x. Right? That's how we find the inverse solution. Question is, what's the domain and range? And to answer that, this is the domain for the inverse function, for f inverse x. Okay. Your range will be the previous domain, which is minus pi over 6 to pi over 8. And the domain will be, we have to calculate that. Okay. The domain for this inverse will be the range of the previous function. So let us compute that. I'm going to compute it here and write the answer above. Okay. Range of f. And how would you compute? The two ends are minus pi over 6 and pi over 2. So let us plug in cos 3 times minus pi over 6. Okay. Will be cos negative pi over 2, which is 0. You can check that on the unit circle. Okay. That is one end. The other end is cos 3 pi over 8 when you plug in x equals pi over 8. Now the function is f of x equals cos 3x. So cos 3 pi over 8. Now you can find the exact value using the techniques from the previous chapter. The sum of angles, like express it as sum or difference of two other angles and expand it and write it. Okay. You can do that. Let me also do it. I will probably do it mentally and write it here. Okay. 3 pi over 8. Pi over 8. Pi is 100. Pi over 2 is 90. Pi over 6. Pi over 4 is 45. And this is half of that. 22.5. You can perhaps use the half angle formula. Okay, under root 1 plus cos x over 2 cos 3 pi over 4 will be negative. So it will be under root 2 minus under root of 2 over 2. Okay, something to that effect. Let me put it this way, not exactly. Either you can use a calculator or do it otherwise. You can get the value. Okay, suppose that's the value of cos 3 pi over 8. So now the range is going to be from 0 to this. Okay, um, minus pi over 6, and from there it will be increasing. Yeah, so the range would be from 0 to that value, whatever it is for cos 3 pi over 8. Okay, all right, moving on. Solve for uh, no, same thing. We find the inverse function and write the domain and range, right? You can go ahead and practice, please, and then check with me. And you want to solve for x, you will say pi minus 1 equals tan pi x over 2, and then you will say pi x over 2 is tan inverse of y minus 1, and then you will say x equals 2 over pi tan inverse of y minus 1, and you will interchange x and y, so you get y, which is the inverse function now, as 2 over pi tan inverse of x minus 1. Okay, that's the inverse function. The domain and range, we'll see. I'll do the calculation here for the range of f. Okay, you plug in minus 1, although that is strict inequality, we're plugging in to get the like endpoint, okay, of that interval. So f of minus 1 will be 1 plus tan minus pi over 2. Okay, now this is going to infinity, right? Tan pi over 2 is infinity. Okay, which is basically if you are approaching from the right, because you are between minus 1 and 1, you want to approach from the right, because minus 1 is the left endpoint, you are going from the right. So if you are going from the right, at minus pi over 2, you are going to negative infinity. Okay, think of the graph of tangent, it will make sense to you. And if you try to evaluate at the other endpoint, you get 1 plus tan pi over 2, and now you are approaching from the left, so that will be going to plus infinity at 90 degrees. Okay, so basically the range of f is negative infinity to positive infinity, so that becomes the domain of the inverse function. And the range of the inverse function is the domain of the original function, which is from minus 1 to parenthesis. Sorry about that. Is it strictly equal? Okay. One more. Now you are used to it. Please pause the video, do it, and check with me. This time the given function is cos inverse, so the inverse of this would be the regular cos function. Okay, cos y will be x minus 1. That gives you x minus 1 equals cos y. To rewrite it, so x equals 1 plus cos y. And you interchange x and y. And you get your equation y, which is the inverse function, as 1 plus cos x. Okay. Now, as far as domain and range is concerned, let's see. Okay, domain of the function f is 0 to 2. For calculating the range of f, we have to do some work. F of 0, if you plug in 0, you get cos inverse -1. And remember the fundamental cycle of cosine, -1 occurs at pi. And if you plug in 2, you get cos inverse of 2 minus 1. And if you plug in that is cos inverse 1, that happens at 0, right? So the range of f, therefore I can say the range of the function f is 0 to pi. Okay, hence now you know the deal with inverse function. Okay, domain of the inverse function is the range 0 to pi, and the range of the inverse function is the domain 0 to pi. Okay, all right, we're done with that lesson. I'll see you when we are solving the equations involving multiple variables. Thank you.